Hello, Math 159 student. In this video, we're going to look at how we can find probability of x when x is a continuous random variable that is normally distributed with mean that is not 0 and 1 anymore, but any number of mu and any number of sigma. So I would call this general normal distribution. The book called it non-standard to differentiate it from the standard normal with a mean of 0 and 1. So X can be anything in real life. It's actually very useful. So X could be IQ score, it could be your height. So all these numbers, if you look at different people, they are normally distributed, meaning most of the people falls in the middle. Then there's some in the high end, some in the low end. They are normally distributed. And if they have this kind of distribution, we can find the probability of them in a range. And the idea is, we talk about it in 6.1, is if we want to find probability of any continuous random variable that is normal, probability of a range of x is what we are interested at. We cannot find probability of a certain value of x, but a range of x. And then this range of x probability would correspond to the area under a density curve, and is also equal to relative frequency. And in layman's term, it is the percentage. So using the same method, we can find the percentage of all population in a certain range of x. Now, there's the tools that we use in our class, in the 159 class, an introduction statistic using algebra would be to use some software tools. And in our case, our tools is always StatCrunch, and we use StatCrunch calculators. We call it the normal calculators when we select normal. Okay. And then, but because this is a general normal distribution, we would set mean actually equal to the whatever mean that they give us, and standard deviation, you have to set it to sigma. Okay, so this is how we, in general, that's what we do. So let's go over to StatCrunch and look at the StatCrunch calculators. StatCrunch calculator is under Stat Calculators Normal. Okay, so by default, when you open it up, it's always a standard normal, expecting you to do standard normal of z-score. But you can change it to any number, so you can change it to any things that they give you. And then you would be able to input the range of x here and get the probability in this box. Again, this is the range of x that you enter, and this is the box that would show the probability. So there's two options that you can choose. By default, it's a standard option where you can find the x that is greater than a number or less than a number. So this is a less than symbol. So you're looking at the number being on the left side. So you can say, oh, less than 70 or 70. Okay, if my mean is 78. So, and then you would compute, and you actually will see that it is indicating or highlighting, or under the area, it would be all the number that is less than 70. And you can do greater than, right? Greater than 7 would be from this onward. And you can click in between where they will let you find, input the upper and lower limit, 70 to 80 compute. So this would be under the curve, the area would be under the density curve between 70 and 80. Now, when we're looking at the x-axis, did you notice that it is not labeled as what we want for standard normal, meaning the middle should be our mean, which is 78, but they just label it in a normal, convenient way. So to change it to a normal curve labeling scheme, we click this 68, 95, 99.7 ticks, and it will give us that. So this is basically how we find mean and standard deviation. Let's just record it. So this is our tool, and there are three cases. So if we want to find, so case A, we find probability of x's between two numbers, x1 and x2. We say we use the between option. Use the between option. And then we say P x1 less than x2, no, x less than x less than x2. Then and then blank this out and do compute. And then the second case is when we do when we want to find probability of x is greater than a number greater than x2, say for example, then we use the standard option. And we when we enter it, we will say x is greater, okay, the x2 that we want, and then this will be blank out, and then we do compute. It will show us the answer in the probability box. We also can find x is less than x1. Let's say lowercase x1, and then we would use standard option again, and then we say x is less than x1, and then equal to compute. So let's do an example. I'm going to copy this example here. So this is the first example that I want to do. Copy. So for example, example 1, we are looking at x, which is an IQ score. So maybe we'll just look at it. IQ scores are biologically determined, so it is normally distributed. And so we want to find out if what is the probability that x is between 93 to 125. And we were given to that the mean is 100, the standard deviation is 15. So there's a few things that you need to pay attention to when you are given a question like this. Is you would look at draw. You would look at let's do a red pen. Oh no. Let's do a red pen. Okay, so you will look at that it is normally distributed. So pay attention to this. Pay attention to that this is normally distributed, and then pay attention to this is the mean, and this is the standard deviation. You need to notice that, and this is x. But you want to find probability. So notice that find probability means find area, and that's between, and it is between 93 to 128. So normally I will draw a normal curve before I use that crunch. I know that it's in the between option, but I'll draw a normal curve. And I'll actually mark the x-axis according to mean, and the tick mark that they give, that the normal tick mark of 1 standard deviation. Oh no, this is 115. And then add 15 again, 130. And on the left side, I will subtract 15. So 100 subtract 15 is 85. And if you don't want to, you can use that crunch, and they will help you. X is between 93 and 125. You would say, where is 93? It's over here, 93, roughly. Okay, 125 is close to 130, so we say 125. And these are the number that's in between them. These are the x number, but I want area. So the area is always above them, but under the normal curve. The area under the normal curve, but above the range of x that you find probability. So you will expect when you use stack crunch, they will show something like that. So let's switch to stack crunch. Enter the mean and standard deviation. In this case, is 115. Do the tick mark so they label them. Label them properly, and you say, well, I want to do what 93 to 125. You compute 63.18. So you go back to your paper and you say probability of x is between 93 to 125 is equal to oh gosh, I forgot what the number is anymore. 6318. 6318. So that's how you do in between. The second example I want to do is this one. find the probability that x is greater than 130, and I already drew the normal curve. I shaded it because greater than 130 means all the numbers is on the high end. I shaded this area, and I used the normal curve. Oh, actually, I did it already. So let's say we'll need to switch it to standard because we want greater than. This is already greater than 130. Click compute, 0.02275, which 0.0228. So I go back to my paper, my notebook, and write down point x is greater than 130 is 0.0228. So that's how you do a question like that of finding probability or finding percentage.